The field study we've done here is focusing on how is the interaction between tire pressure and fuel economy and fuel efficiency during tillage work. What initially made me do this study is actually that I experienced a lot of farmers running with the same tire pressure all year round for all conditions. And as an agronomist, I think that is not the most optimal way to use your tire, because a high tire pressure will also induce soil compaction in your fields. And we all know that soil compaction will actually hurt your yield. So as an agronomist, my key thing is try to reduce the damaging of the soil and reduce soil compaction. And one way to do it is reduce the tire pressure. The study here is done on a potato field, been harvested last week. And what is done here is a primary tillage before a seedbed tillage pass that will come in a few days, followed by the winter wheat seeding. So doing the test, and we are having testing 0.6, 1.6 and 2.0 bars. I know that many farmers will think, oh, 0.6 bars, that's a low tire pressure. I have the same feeling. And I've been working with the Valtra here for over a year now, and I've really been testing it and really basically putting a char marker on the tire to just observe whether slipping were occurring, but I did not see any of it. And I've gained the confidence that the VF tires can really have a lot of traction even at low tire pressures. And I think this is a key finding for me, because I know many farmers that I talk to, they are afraid to reduce the tire pressure based on the fear of the risk of tire slipping on the rim or complete tire falling off the rim.
I know that the farmers, especially when they are reducing the inflation pressure of the tire, they have some concern, some fears. Two mainly. The first one is the rim slippage and then the rim roll-off. But since the first moment that Bridgestone was designing the tire, VF technology, we have completely redesigned the contact area in between tire and rim. So we use a new shape of the bead that we are calling S-line bead shape, that is guarantee a perfect adhesion between rim and tire, especially at the low inflation pressure of the tire, so no problem at all. When you are passing from an inflation pressure of 1.6 bar to the lowest one allowed, that is 0.6 bar, there is an effect. So the footprint is increasing its length, not its width. Width just a little bit, but not like length. Length is up to 45–47% more. As a matter of fact, you can simply count the number of the lugs that are touching the ground when the tire is inflated at 1.6 bar, usually are a couple, and when it's deflated till 0.6 bar, they are reaching 4. So it's a good indicator for the farmer and for the contractor that the footprint now is longer and the contact pressure is reduced because the area is increased a lot.
We're using the Valtra Q305 here for this test, and we have added 1.8 tons at the front here at the ballast, and we also have wheeled rear weights added to the tractor. That way we can create a static ballasting of roughly 50–50% weight distribution between front and rear, and then as we move into the dynamic pull during the study, we see a weight transfer from the front to the rear, so that we are operating under the ideal 40% weight on the front and 60% on the rear axle, which is the ideal for tillage pulling. The Valtra Unlimited CTRS system, central tire inflation system, is actually factory fitted, and it's controlled via the Valtra Smart Touch display from in the cab. And one of the unique features is that you can actually increase the tire pressure and decrease it during transport. I mean, on the road or as you come into the field. So let's focus on the results. We see a 7% reduced fuel consumption when we move from 1.6 bars tire pressure down to 0.6. That amounts actually to 1 liter fuel less burned per hectare. And then as a farmer, you can convey that into and relate that into your conditions. Another finding is the field efficiency. The field efficiency actually increased by 1.8% with the lower tire inflation of 0.6. And this is due to the fact that if you reduce the tire inflation, your rubber that is touching the soil increases, the area increases significantly, and that reduces the slippage between the rubber and the soil. And that actually in the end amounts to higher field efficiency. Now looking at soil compaction, we actually see a 17% lower soil compaction when we are working with 0.6 bars tire inflation compared to 1.6. And I think from a farmer perspective, this is very interesting because soil compaction is the thing that are reducing your yield potential today. So whatever you can do to reduce soil compaction will in the future increase your yield potential. And your yield potential is what you're going to live off into the future.